GM everybody, hope you're having a great day. My name is Yasin and welcome to the second week of our Chain Abstraction Educate series. Really happy to have you all here. So feel free to say hi, where you're all coming from in the chat section while we kick off the third event of our series, where we have Prabal, who is the co-founder of Avail, come in to host a workshop on Nexus, the true unification. I'm going to quickly add him on stage. And we can get things going. Chat sections at the bottom right, everyone. Feel free to ask your questions there or within the dedicated questions tab if you have any. And for those of you that are wondering, this workshop will be recorded and will be added to our Hacker Pack Hello Prabal on stage. We will make sure that the recording is made available to all of you within the next 24 hours, and we will make sure to post it both, as I said, in the Hacker Pack as well as the Discord section. So thank you all for being here, and welcome, Prabal. How are you doing?
I'm good. How are you?
Very nice. Excited to kick things off.
Same here.
Yeah, feel free to take it away.
Okay, I can start, right?
Yes, of course.
Great. Hey everyone, nice to meet you all. Today I will be talking a bit about unification and how we attempt to have unification within the L2 ecosystem, and that is through Avail Nexus. We will talk a little bit about what is the motivation, how the landscape today looks like, why are we building Avail Nexus and the other parts of the Avail stack, and then go on to describe a little bit on the technical inspirations and how we are aiming to solve the problem. So that's roughly it. Before I dive into it, just wanted to introduce myself a bit. I'm Prabal. I came from a very academic background. Before joining the crypto industry, I had been doing blockchain research and then dropped off my PhD program after 4 years of research to join Polygon and led research there. And Avail was built as part of that engagement. After almost 3 years there, we took Avail off and spin off as a separate entity. That's a rough journey of myself. In terms of what we are trying to build at Avail, we are trying to build what we like to call the unification layer for Web3. As part of that, we essentially are building 3 different components. Avail DA is the base layer, which is essentially what is responsible for data availability. I will talk a little bit on what is data availability and what is the rollup landscape in a bit more detail. But roughly speaking, that part of the stack is what is there in production today. We launched the mainnet quite recently, and that is where the rollups are using for data availability. Avail Nexus is the verification hub where we aim to unify the rollups and the different chains. That is what I'm going to talk about mostly today. And then we have Avail Fusion, which is a way to have additive cryptoeconomic guarantees on the rollups. And probably I will just touch upon that a little bit. So what is Avail DA? Before even I go there, I just want to, because I don't know from the backgrounds of all of you guys who have been listening. So we know that rollups are the dedicated way to scale blockchains today. We have seen many different rollup stacks coming up, but L2s more specifically trying to take the computation from on the base layer to the L2s themselves. By doing so, they reduce the load of the base layer itself, where the base layer doesn't have to do much of the execution. It mainly takes a look into the data availability guarantees and the executional verification. So that's the way how rollups work. In this kind of a world where there are hundreds and thousands of rollups, and just wanted to mention, when sometimes it's misunderstood about the kind of rollups we are envisioning. Are we envisioning like hundreds of general purpose rollups? Are we envisioning like there will be thousands of arbitrums or zk sync or zk EVM? OP optimisms or such. How we like to see the world is not like that. How we envision the world is there will be thousands of application specific rollups. What that means is we would like to have these rollups all specialized to solve only one of the things, and there will be a very few number of general purpose ones which, as we see today, are dominating the rollup landscape. So that is the rollup centric roadmap that we are looking for. And in that kind of world, what Avail DA does is that it scales rollups. Now, how these rollups work, as I told you, is that it takes this computation off chain, computes the outcome of the transactions, and then provides an on chain proof that the off chain execution was done correctly. This is the typical way in which the rollups scale execution. But one of the major bottlenecks of this type of scaling is that the base layer needs to have DA guarantees. What that means is the base layer needs to know that the data behind that execution is available and that the execution was done on the data which has already been published. So that's why data availability or data publication is what is one of the major bottlenecks of rollups today. And we, from 2020, we're trying to solve this particular problem. Now, of course, there are many ways to solve a problem, right? So one of the major emphasis of our design was that on verifiability. We wanted the end user to have very high levels of guarantees that the data is available. And we didn't want them to having to download all the data and check whether the data is correct or not. We wanted very efficient verifiability, and that's why we went for a more validity proof driven approach. We used case-rich polynomial commitments so that very efficient light clients can verify DA without the need for fraud proofs and such. Like there has been examples where the light client has been running inside Raspberry Pi or a smart watch or something like that. So that's the level of verifiability which we wanted. And with the DA layer being on mainnet now, this is the first stage that we have reached, the first milestone which we have reached within the Avail ecosystem. Coming to Avail Nexus, this is going to be the major emphasis of today's discussion. So mainly we are trying to make a permissionless verification hub. And what that means is we are trying to aggregate the proofs from different rollups, and even within the different ecosystems that are there. We are trying to make sure that the DA guarantees that come from Avail DA are leveraged upon, and that the entire proof is not only the guarantees of execution, but also guarantees of ordering. So only when you have guarantees of ordering and execution together, along with the data published, then you would have very high guarantees of the correctness of these rollups. So we are trying to enable that using Avail Nexus. There's a part of sequencer selection in which we would not want to run sequencers, but we would want to have a module which allows for different sequencers to be selected as part of the rollup stack, so that rollups can be not only be verified in a permissionless manner, but also be run in a permissionless manner if the rollup deployer wants it to be so. So that's roughly Avail Nexus. And then in Avail Fusion, what we are trying to do is we are trying to have additive cryptoeconomic guarantees. Of course, the Avail DA layer right now is secured by the Avail token, but we want to have additional cryptoeconomic guarantees from the different ecosystems like a Bitcoin or an Ethereum or any other rollup specific token. So that's what we want to allow the other tokens to actually have guarantees added on to the Avail ecosystem. And that's what we are trying to do in Fusion. And one of the major differences from what you might have seen in other places is that we want all these tokens to actually have a role in the consensus itself. So it should be not only about the double signing or cryptographically attributable false, but also about the liveness guarantees and such. So that's the That's the major reason why we want all these tokens to play a role inside our grandpa consensus, which powers the Avail DA. Now, let's dive directly inside Avail Nexus and what we are trying to do. In a nutshell, we are trying to have trust-minimized rollup interoperability. Now, what do we mean by that? What are the trust assumptions? What do we mean by trust-minimized interactions? And what is the interoperability problem, so to say? Now, we take a lot of inspiration from Web 2. One of the things that we would definitely want is the developer and the user experiences to be that akin to how Web 2 today is, because of how it is able to scale, how it is able to provide much superior user experiences, but at the same time hold on to the ethos of Web 3, which is all about verifiability, about guarantees, about having censorship resistance and such, right? So those are the main guarantees for which we want from Web3. Now, if I take a kind of parallel example from the Web2 world, if you think about how you go into a marketplace and buy a product. For example, you go to Amazon, you want to buy a particular product, you add it to the cart, and then you go and check out. What happens when you check it out? It essentially makes an API call to a payment aggregator, let's say a PayPal or a Stripe or something like that. Now, the PayPal doesn't know about your banking information. When you enter the details of your card, it determines whether it's a Visa or a MasterCard or an Amex. And based on that, it makes another API call to, let's say, a Visa. Now, Visa also does a similar API call to your bank. Your bank is what, in most times, it fulfills the call. And once it fulfills the call, then it gives the call back to PayPal. PayPal gives a call back to Amazon. And Amazon at that point in time knows that the payment request has been fulfilled, and hence the item that you wanted can be actually shipped or can be moved to the next stage of the interaction. This is very elegant because of two different factors. The first factor is how essentially independently these individual entities can scale. For example, during a major sale, there will be huge amounts of load on Amazon, but it might not translate to more load in the banking infra. But each of these individual services can scale because of the microservices style architecture and the API calls that are interacted between each of them. That's one. The second part is what we want to change is how there is a trust between Amazon and PayPal, and how it is all kind of, if PayPal tells Amazon that the payment has been done, then Amazon just believes it and proceeds forward. We want to change that in the Web3 world. But sadly, this is how the Web3 interaction and the Web3 interoperability space looks today. If you see a typical cross-chain bridging experience, let's say from an Ethereum to another Cosmos or any other L1 chain, there are many ways to do it, of course, but one of the more canonical ways that we have seen this implemented is what we call as a lock and mint mechanism. So what happens is on the source chain, let's say Ethereum, you go and lock your assets, and then that particular ledger is kind of communicated to Cosmos. On Cosmos, you verify whether the source chain has actually indeed locked it or not, and based on that, you mint. On the reverse side, you essentially burn on one chain and unlock on the other. Now, this is the cumbersome procedure which you have to follow, but more importantly, you have to realize that there is no way for Cosmos or any other L1 to verify the executional guarantees of Ethereum. So what it does is it relies on the consensus guarantees. So it verifies, and I'm talking about the best of the bridges, the most secure of the bridges. What they do is they verify that the consensus of Ethereum asserts the fact that this asset has been locked on Ethereum. This is because even if you give an entire ZK proof of the Ethereum guarantees, you will still not be able to have the availability of the data and those guarantees behind it. So the best you can do in L1 cross-chain interaction is you have to rely on the consensus guarantees. This was even fine, but when you have many different chains, this quickly becomes a mess. As you can see, essentially, if there are users in many different chains and then there are multiple of these chains working together, the interactions can get quite messy. There can be, a lock and mint on one chain, which gives you a wrapped asset on the other, and then you lock that asset. You get another form of a locked asset, and then depending on which particular flow your asset took, you can have different wrapped versions, which can have different security guarantees and such. So this quickly dwindles down to a very much fragmented experience, and not only that, a lot of delays and such as well. Now, as you can very well realize, with many different chains, the L2 fragmentation just gets worse and worse. Even if you have, let's say, here we are showing only 8 number of chains, and even if you use the best of the guarantees, which are light client enabled guarantees, then there needs to be light clients, and then you basically get down to NC2 number of bridges, where N is the number of chains, because you want one interaction between all the 2 different rollups, or all the pairs of rollups. But if you think about it, this doesn't have to look like that. What it could look like is something like this, where you have the different rollups, which all have light client of the data availability guarantees and the execution proof guarantees. And then you can have a centralized, a central place like a nexus. It may be centralized, it might be decentralized, but a central source of information like a nexus, where all the different rollups can be verified of their execution guarantees and DA, and then you can provide those guarantees back to each of these chains. That's what essentially is the guiding factor towards building Nexus. And hence it looks something like this, where you have multiple of these chains. Each one of these chains have a single connection to the Nexus middleware, and hence it can not only prove that it did its execution, it performed the state transition function correctly, but it can also verify that all the other chains had done their executional job correctly as well. So that is the power of Nexus here, and that's what we want to enable. Like, what is the end goal that we are looking for? In the end goal, we are looking for something like this, where let's say there is a NFT marketplace, let's say an OpenSea, and then there's a payment chain, let's say a Polygon zk-AVM or Arbitrum or OP or Optimism or something like that. We want the Nexus to be the processing engine in between, where you can buy an NFT contingent on the balance transfer on the L2. So for example, suppose, like for example, in today's Web2 world, when you go and book an airline ticket, how it typically works is till the point where you go and verify, you go and fully complete the payment, your seat is actually put on a hold state. So there is a timeout, let's say a 5-minute or a 10-minute timeout, till when the seat is put on the hold state. If you go and complete your payment within that time, then the seat is actually given to you, or the seat is pushed back to the pool so that anyone else can book from it. And this is also the same kind of thing that we want to do within the Avail Nexus. At least this is one of the things that we want to enable through Nexus. And there we want to what we are trying to do is, on an NFT chain, you put the NFT in a checkout phase, so to say. On Nexus, you go and provide the payment guarantee that the payment was actually indeed processed on the payment chain, and then OpenSea just transfers the NFT to you. That is roughly one of the demo that we already have as part of what we are building through Nexus. We have this as part of a repo called zk-NFT. So if you guys are interested, you guys can check this out. This is called zk-NFT. This is part of the Avail project repo. Great. So, but how does all of this work? Like, what are the technical challenges? This is all sounding so simple. Then why is it that not many people are doing it, or what are the main technical challenges towards doing something like this? So, one of the major technical challenges here is the fact that if you look at the different L2s, the different L2s provide different forms of guarantees. I will take the ZK examples today because the optimistic ones are much harder to reason about because there are cryptoeconomic guarantees as well as cryptographic guarantees, along with game theoretic ones which come into play in the optimistic setting. But if we talk about the ZK setting, then roughly speaking, let's say you typically have three, four, five different ZK rollups in production today. Let's say you have a ZK sync, you have a Polygon ZK EVM, you have a Starkware's StarkNet, you have Scroll, Linea, and others as well, right? So out of these ZK stacks, if you look at their different proof systems, they are all very different. So each one of these rollups have different proof systems which they use in order to have guarantees of execution. Now the main problem is that when you take the heterogeneous proof systems together, it creates a problem on how you want to aggregate them. So what we are trying to do here is that we are trying to provide an adapter which takes proofs of different kinds, all the heterogeneous proofs together, and provide a homogeneous proof on top. Now, in this example, we are taking Groth16, but in reality, Groth16 proofs are the wrapping on the Groth16 is not always optimal unless it's on the last step where you want, smart contract verifiability and such. So not going into those details, but essentially all these rollups today have some form or the other of a Stark proof as the intermediate proof. We are trying to aggregate those Stark proofs together, or in some cases when the Stark proofs are not available or not exposed, then we are trying to take the Plonk proofs together and then aggregate them to provide a single aggregated proof. This is what goes as part of the Nexus runtime. Apart from this, what also goes into the Nexus runtime is very simple checks about the consistency of the proofs that are submitted. For example, whether the proof is sequential, whether this proof follows that from the last proof, whether there is continuity of block numbers and block hashes and such, or if the events are generated in the correct format, whether the order is according to the base layer, which is, let's say, Avail DA or something else. These are the correctness checks which are done as part of the Nexus runtime. In reality, we want to keep the Nexus runtime to be extremely simple and extremely agile, so that different types of checks are done kind of outside of the Nexus, whereas the Nexus is essentially very much ZK driven, very much a very light runtime that just coordinates the different rollup proofs. And this is how we are trying to do it. This is, of course, one of the designs. We have a few parallel designs which we are trying out. So do not hold me to this design in the final shape and form. But roughly speaking, if you're a user and you want to buy an NFT, what you do is you interact with the marketplace. You go ahead and provide the buy NFT call along with some payment details. For example, which chain and which kind of account you want to use on that chain and so on. When you go to the NFT chain, the NFT chain actually holds the NFT for you. And as part of that, it provides a call to the Nexus middleware that it wants some kind of a receipt route or a proof of inclusion or a proof of exclusion from the payments chain. Now, the payment chain independently, it processes these transfers, and then once the transfers are processed, it provides a ZK proof along with some state routes and receipt routes back to the Nexus middleware. From there, anyone can verify in a very cryptographic manner whether a particular transfer was done or was not done. And this is very, very crucial. What I'm saying here is that in a general ZK sense or a validity proof driven sense, if you do not have proofs of non-inclusion, then there are cases where the execution was done or the payment was processed, but you just do not know about it, or you do not have a verifiability of it. Whereas here what we are trying to do is we are trying to provide both proofs of inclusion as well as non-inclusion, so that you know for a fact whether the transaction was done or a timeout was reached without any transaction corresponding to this being done. And this is one of the main superpowers of being verifiable interaction between rollups, right? This is what makes the entire interactions much like many. This is what makes it trust minimized, because you do not need to trust the NFT chain, doesn't need to trust the payment chain. All it has to do is it has to verify the ZK proof from the Nexus, and that itself inherently verifies whether the payments chain was doing the transfers properly or not, whether there was, like, it ensures that there is no double spending, there is no double signing. Those kind of things are already taken care of by the state transition function of the payments chain. That is the crux of what we are trying to do here through Nexus. That's why the NFT chain can not only do this, but this can be, extrapolated to, for example, let's say you have an ERC20 token here, but to buy in your wallet you have some ERC20 token, but for the NFT to be bought you probably need ETH. And then how do you go about to doing that? You can include, let's say, a DEX chain where you can basically swap your assets. You can swap your assets, buy the NFT, make the payment, then swap it back to your original asset class, and all of them can be done in a trust minimized manner, because you can verify each one of the state transition functions, their ordering guarantees, as well as the inclusion or non-inclusion proofs. Great. So what does it look like? Like when everything of this is done, what does it look like? What is the end user level guarantees? What are we talking about? Are we talking about only the clients being able to verify? Are we talking about the rollup stacks being able to verify? Or are we talking about, end user being able to verify? And here we take a very, very opinionated approach. We want this to be end user verifiable. As I mentioned, that is exactly why we have been so hell-bent on using validity proofs, on using KZG polynomial commitments inside the DA layer, because that gives very, very efficient light client data availability sampling. And only when you involve data availability sampling along with execution proofs, you get the full power of what is possible in a rollup stack. And that is exactly why we try to take this approach with Nexus as well. What we are trying to do is think about the Nexus adapter and the Avail DA light clients being all verifiable by the end user. But how exactly this is done is, let's say you have these three rollups working together. The rollups provide the proof. The proof is of execution. So it just it just checks the fact that a post state was reached from a pre-state after executing these transactions. That's what these proofs kind of enforce. What the adapter does is it takes all these proofs, it aggregates them together to provide one aggregate proof. Mind you that this aggregate proof can be a simple Groth16 proof wrapped, which is of constant time to verify. This is almost like in a few hundred KBs. It can be verified in, let's say, a 60 to 100 millisecond. So all of this is extremely, extremely efficient. This aggregate proof can be made to be, constant sized and constant time verifiable also, but there are more efficient things which are coming up every day. But not only that, this aggregate proof will be verified against the ordering guarantees. And that is why it is so important to take these rollups with a view towards where the DA is. So when you get the ordering guarantees, you can take a ZK Sync era, or let's say a ZK AVM or other L2 stacks, you can take their ordering guarantees and then have the DA guarantees also verified by light clients, because you can then sample only parts of it and get very high levels of availability guarantees. When you put both of them together, what you get is the full guarantee of what a rollup provides. The rollup inherits the security from the base layer only when you get DA guarantees and the execution guarantees together, which is verifiable by the end user. And hence, this is what we envision to be the final state. You have both execution and DA kind of separated as part of the modular thesis, and the modular chains are increasingly trying to do something like that. When you have n many of these modular chains, this creates a very much fragmented experience where the users don't know or doesn't have a clue where their assets reside. And not only that, you have to rely on either a liquidity provider or a full node or a super node in order to provide guarantees of one chain on the other. What we aim to provide is a unified user experience and developer experience which has user level guarantees, and that we do using running a light client, which makes this experience very much unified. So yeah, I mean, in the end, what we want to do is through Avail is accelerate the unification of Web3 by allowing these modular frameworks to scale and interoperate in a secure and trust minimized way. So that's what we are trying to do in Avail. I'm happy to dive into a lot more details of each of the things that I talked about. Happy to answer any other questions, happy to answer like how we aim to do it on ZK rollups of a particular kind or such as well.
To remind people that yes, you can post your questions on the bottom right side. You can see the chat section as well as the question section. Really interesting presentation from Prabal. So maybe you guys can follow up with a few questions. In the meantime, as a reminder, the presentation will be recorded and will be provided in the next 24 hours. We will make sure to post it on the Discord as well as add it to our hack pack. Questions, everybody? I can see Adam typing. Prabal, when you're answering questions, I would suggest to read out the question itself, as people watching the recording would also get the insight of what the topic was.
Yeah, so Adam is asking, could you explain the Nexus adapter again, if only briefly? Thanks. So yeah, let me go to the adapter. So what I meant to say with this adapter is, if you take a look at very specific example, let me take specific names and their proof types. If you have a Starkware Starknet, it has a Stark proof. Whereas if you take a look into, let's say, a ZK Sync era, it has a modified Plonk proof. It doesn't use the Plonk proof system directly, it uses a modified Plonk system. Whereas if you take a look into, let's say, a Polygon ZK AVM, it uses what is called as an F-Plonk proof. So it's an upgrade on the this is one of the latest things that has been done on the Plonk research. When I say latest, it's not that latest also, because every day new things are coming up. But it's one of the newer primitives that is coming up in Plonk. Now, when you take, let's say, a Stark proof and two types of Plonk proofs, how do you aggregate them together? That is one of the problems here. Now, when you have heterogeneous proofs, to aggregate them in a single proof system, it gets quite tricky. So what we aim to do with the adapter is we aim to take the proofs from different kinds, proofs of different kinds, put them through the adapter, and then have homogeneous proofs coming out of the adapter. So think of the adapter being a verifier, but using the same proof system all along. For example, what are we concretely doing? Let's talk about again concrete implementation of the adapter that we are doing today. We are using RISC-0 or SP1. We basically have a adapter where you can plug in the backend. So you can use a RISC-0 or an SP1. The adapter is essentially written in Rust. So the Rust code is essentially a verifier of the proof that it caters to. For example, for ZK Sync, this is an mplong verifier. For ZK EVM, this is a flong verifier, and so on. So the adapter is essentially a verifier. Because all of them have been written in, let's say, an SP1 or a RISC-0, they can always be composed together very efficiently. They output start proofs, which can be composed very efficiently and then wrapped into a Groth16 proof, which is verifiable on-chain. So roughly speaking, that is what I mean by an adapter. Hope that helps.
There is a question in the questions area.
Yeah. So can you talk about the DX, including what tools developers should use to develop with Nexus? Yeah, this is one of the trickier questions here, essentially because we are trying to design the system so that people don't have to use specialized tools. Having said that, it is always quite tricky. One of the things which we envision is we want to write those adapters and the entire experience for most of the rollup stacks that are available today. For example, let's say a Polygon CDK, let's say a ZK Sync hyperchain, or the ZK stack, or a Madara app chain stack. We want to write those adapters and the entire implementation for them as much as possible. In terms of what the developer then needs to do is essentially just talk to a contract, which every developer almost knows. We will provide standard templates for the contracts so that people can just use those standard conventions and use that to interact with the Nexus. We will even provide the Nexus proof as part of a contract already available, deployed and available, which means that people can just have their contract talk to the Nexus contract in order to have the proofs ready for them. However, as I've told you in the very beginning, like we don't just envision EVM stacks. So when I say all of this, I'm kind of only talking about the EVM stack. So what about the non-EVM ones? For example, as part of Madara, which there's no smart contract per se, you have to write the Cairo program. Or for example, if you take a sovereign SDK or a stacker or something like that, when you want to take a look at the app specific chain and the SDKs built for that, the reality is that we need to first understand what tools they give to their developers, and then we will have probably extensions on top. Because when you talk about very much app specific state and app specific transaction structures and such, the EVM method that I was talking about, it does not apply there anymore. So we have to look at what the developer experiences are there for those stacks and then build on top of that. Hope that answers the question.
Any other questions, everybody?
Yeah, I just wanted to, because there are not many questions, I just wanted to, leave you guys with one kind of thought, is that I tried to explain these in quite kind of, at a very high level, but there are, much trickier things to consider when you go ahead and think about the adapter. For example, let's take this kind of a guarantee. Suppose all of these examples that I took that of a centralized sequencer based rollup, right? All of the examples here are that with a sequencer, either a trusted sequencer or sequencers with forced transaction and forced inclusion and so on. So that is all fine, but let's take an example of, let's say, a Tyco. When you talk about a based rollup example, some of the things that I just glossed over become much more trickier. For example, in a typical sequencer based rollup design, what happens is the sequencer batches these transactions together and then provides a single blob back to the base layer, right? So that's how the sequencer based designs work. But suddenly when you have based rollups, the users directly send the transactions to the base layer, which means that you not only have to give guarantees that over the blob that the execution was done correctly, but you have to also give guarantees that all the relevant transactions were actually considered. Now, it might on the face of it seem trivial to do so, but if you think about it, you are now talking about completeness and soundness guarantees. The soundness guarantees were almost enough with terms and conditions applied, but the soundness guarantees were enough for a sequencer-led rollup, but for a based rollup, suddenly you have to give completeness guarantees as well. The completeness guarantee being that I, as the prover, have actually taken all the transactions which were submitted to the DA layer, which is relevant to this rollup, and I have executed all of them. I have filtered the incorrect ones because it's a base rollup, I can always push a invalid transaction to the base layer. So you have to take all of that. You have to prove that all the transactions were included, the wrong transactions were ignored or were not processed, and then the transactions were indeed actually wrong, and so on and so forth. So just wanted to just dive a little bit on the complexity of a based rollup design and how, when you have different kinds of rollup designs, the guarantees and the design complexity kind of changes. So yeah, that's the last thing probably I wanted to mention.
Final chance for questions, everybody. In the meantime, let me quickly showcase our next speaker for the week. Let me quickly share screen. As you've seen, we've just had the workshops by Prabal, and coming up on Wednesday, we're going to have Brian Sung, who's coming from Polygon, on what is Avail and how seamless cross-chain UX is achieved. For those of you that have found that are interested, please make sure to mark your calendars, and the event is going to take place this Wednesday from 4 p.m. BST. Invites should be in your calendar, as well as the links to watch live. Other than that, I don't see any other questions. So thank you so much, Prabal, for coming for this workshop. It was a really interesting topic to follow. Thank you all for the questions as well. And as I said, recordings will be made available real soon. Last words from yourself?
Thanks a lot for attending. If you have any more questions, feel free to reach out. We'll be happy to chat separately. Thank you.
Fantastic. Thank you. Have a great day, all. Thank you, Prabal, once again, and see you all soon. See you all.